Hello, good to see you again. Welcome to Block 4, Operations and Equations with Directed Number, Lesson 8. I'll share my screen. In your previous lesson, you learned how to perform division and multiplication, or multiplication and division of directed number. Directed numbers are positive and negative integers. In today's lesson, you're going to learn how to use a calculator for directed number calculations. It is a very important lesson, I must tell you, because it is one of those items or issues in maths where students really don't know how to effectively use calculator to do complex calculations. Before we start, like the video, share the video with those you think can benefit, subscribe to the channel, and click on the notification bell so that when new videos are uploaded, you will be notified. By doing this, you help us grow our mission to provide a platform where children can have high quality maths education regardless of their economic circumstance. Thank you. Before we start, I would like you to do the retrieval practice question in 4 minutes. Assuming you have paused the video and you've answered the retrieval practice questions, here are the answers for you to review and mark your work, hence celebrate your success. Here, we're simply practicing how to do substitution. So remember, substitution, you simply replace the letters with the numbers that you've been told the letters represent. So here we've been told A represents 3, B represents 0, and C represents 4. So wherever we find these letters, we'll replace those numbers with them. So for the first one, we'll have 3 add 0 add 4. The next one, we're going to have A squared, which is 7. The next one, we're going to have A squared add C. A is 3, so we're going to square 3 and then add 4. The answer should be 13. The next one, AC in algebra means A times C. So whatever A is, we multiply it with C, and that gives us 12. The next one, we have A squared plus C squared. So whatever A is, we'll square it, and we add it to squaring whatever C is. And that should give us 3 squared, add 4 squared, which is 25. The next one is a bit more complicated than the others, but it's not too difficult. So we will square whatever C is and we'll multiply that by 4 because 4C squared means 4 times C squared. So that gives us that. And then AB means A times B. That gives us the result of 64. Next, we're asked to use a calculator to perform this calculation. So if we want to use a calculator to do this, we must use the fraction button, and then we'll use the calculator key, arrow key, to push the cursor to the top of the fraction button. We'll key in 36. We put squared plus 7.68, and then we bring the cursor back to the bottom of the fraction display, and then we type 4. That gives us our result. Okay, let's do some new learning. Dora wants to find the square of -8. What two calculations could Dora use to do this? Have a think. Well, Dora could 8 squared. To square something means to multiply that number by itself. So to square a number means to multiply that number by itself. So Dora could do this, which is 64. Dora could also do this in a calculator by using brackets with -8 in those brackets and then pressing the square button, which is also 64. Notice the square button because in the next slide, I'm going to tell you why it is important and why we use it. Mo and Dexter are trying to work out the square of negative 11 using a calculator. So pay very close attention to this, I must say. Mo's calculator gave this result, but Dexter's calculator gave this result. Who is right? Explain why. If you think Mo is right, explain why. If you think Dexter is right, explain why. Okay. If you think about it, Mo is not correct. So what Mo has done is the calculator does order of operations. So it does the square of 11 first, and then it appends the negative sign to the negative 121. To 121. But Dexter has solved that problem using brackets, knowing that the calculator would not do it properly. So to square a negative number, you must put it in a square in the brackets. So, and that gives us 121. Let's look at another example. Eva wants to substitute two numbers into this expression. Here is what Eva did. So she substitutes x equal to 6. She got 60.8. She substituted x is equal to negative 0.6. She got the same result. Why do you think that is? Oh, well, something you need to know is that negative 6 is the same, negative 6 squared is the same as 6 squared. Let's check it. When we have negative 6 squared, this is what we mean. So negative 6 squared means negative 6 squared means negative 6 times negative 6. Now, did you remember from our previous lesson what multiplying two negatives will give us? It will give us positive, so that is positive 36. And that is the same as 6 squared. 6 squared is 6 times 6, which is 36. So Eva is right. Now, Eva then substituted x is equal to 6 and x is equal to negative 6 into the expression 14.3 minus 3x divided by 2.5. Now, something interesting happens here. Explain why the results will not be the same. The results will not be the same. Explain why. Well, take note that 3x means 3 times x, right? So if we substitute x is equal to 6, we will have 14.3 minus 3 times 6. Okay? 3 times 6 is not the same as 3 times negative 6. So if we were to really write this out, this will be 14.3 minus 3 times 6. Okay? Which will be, so this one is different, 2.5. So this will be 14.3 minus 18, okay? Divided by 2.5. But for this one, when it is negative 6, watch what happens. 14.3 minus 3 times negative 6 divided by 2.5. So I'll continue here. This will be 14.3 minus, remember, 3 times negative 6 is negative 18. So this minus is still there, but 3 times negative 6 is negative 18. And then we divide by 2.5. Do you remember what we said? Two negatives next to each other, they are invisibly multiplying each other will become? positive. So you can see why your result will not be the same. It's a very important concept you need to know when you're using calculator to do directed number calculations. Rosie, here's another example. Rosie wants to work out the calculation negative 13.5 at 6 divided by 12. On a calculator, Rosie calculator does not have a fraction button. So how would Rosie do this calculation without making a mistake? Now check what Rosie would have done first time without a calculator. What has she done wrong? Well, if you think about it, this calculation will do the division first. So remember BIDMAS, okay? We've learned about this in our previous lesson. So this will be 6 divided by 12 first before it does any other calculation. But that is not what we've been asked to do. From the question, we've been asked to divide the whole lot of negative 13.5 plus 6 by 12. So to address this problem, Rosie has to use brackets, okay? Rosie has to use brackets. So she has to, the brackets, of course, remember BIDMAS is telling the calculator what to do first. So without the fraction button, this is what Rosie would do. Okay, it's now time for you to pause the video and do some practice. So pause the video and answer questions 1 and 2 in 5 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. So this is simply using your calculator to do this, practicing with your calculator. So mark your work and celebrate your success. If you didn't get this right, make sure you review this and practice again. Pause the video. Here are the answers for question 2. So mark your work and celebrate your success. So this is simply calculator doing its thing. All right, next. Now, before we move on to the next practice question, I want to make a comment on this. Notice what your calculator would do with these. Okay, remember what we learned. The positive and the negative next to each other must be invisibly multiplying each other. So that would be negative, that would be negative. So if I were you, I would try to do it, with the calculator, typing this exactly in the way the question is, and try to do it using what we've learned, and you will be pleasantly surprised at what you get as your answer. Okay, really, really important concepts. Okay, pause the video and answer questions 3 and 4 in 4 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So you're asked to explain why all these fractions are equal. So negative 3 divided by 8 is negative 0.375. So using your calculator, you can demonstrate this. This one means negative 3 divided by 8, you'll still get a negative answer. And 3 divided by negative 8, you will still have a negative answer. So that's why they are all equal. Next, you were asked to use the inequality symbols to do these calculations. So this is a very good point for you to practice everything you've learned. So if you were to do this in one go in a calculator, I want you to do that. Write your answer on the side and then check the results you get when you... Is that stop moving? Okay. Check the results you get when you combine these signs using what we learned. So the negative, positive, and the negative will be negative next to each other. This will be positive. These two will be negative. So do it without doing what we're doing now, and then do it separately, checking what we've done, and you will be pleasantly surprised at your result. Okay? I didn't mean that to be that long, so let's rub it off. All right, so that's what we want. This. You will be pleasantly surprised at your result. Okay? These two will become negative. All right? These two will become negative. You will have really interesting results. Okay? It's just to help you really understand this concept really well. All right. Having done your practice for the first part of the lesson, where you use your calculator to do directed number calculations, we're going to now extend our learning to learn about linear sequences that involves directed numbers. Remember, directed numbers are positive and negative integers. So here we're asked to find the next three terms in the linear sequence. Now, remember, what do we know about linear sequence? We know that for a linear sequence, we are adding or subtracting the same amount every time. So we have to find a common difference. Okay. So what is the difference between 2.3 and negative 1.7? Now remember what difference is. It's like saying 2.3 minus 1.7, because we're trying to subtract one from the other to find the difference between them. Now, this is the same thing as 2.3. Remember, these two will become positive, so that's 4. Okay, so that's 2.3 plus 1.7, which is 4. But take note, it just tells us what the common difference is, but we have to know what we're doing with the common difference. Now, we have moved from 2.3 to negative 7. So it means we are decreasing by 4 every time. So if we keep doing that now, you use your calculator, you do, okay, we have to subtract 4. So you do negative 1.7 using your calculator minus 4 will give you the next one. And that's how you get your result. Next one, negative 5.7 minus 4. And that gives you your result. Okay? Let's look at another example. This time, we're talking about geometric sequence. Well, you may not have heard of this before, but geometric sequence is a special type of sequence. Now, for geometric sequence, you are either multiplying by the same number every time to get the next term, or you're dividing by the same number every time to get the next term. But how do we find that number? We find that number by dividing the second term by dividing the first term by the second term. Okay? Now, when we do that, we will find that the number will be negative 2.5. Okay? So you divide the second term by the first term. So if you do negative 0.75 using your calculator divided by 0.3, you will find that your result will be negative 2.5. And then once you get that number, you say, okay, negative 2.5 is the special number that you are using to multiply every time to get the next term. So that will be time to get the next one will be negative 0.75 times negative 2.5. And then 1.875 times negative 2.5, so on and so forth to get the next three terms. Okay, I want you to pause the video and try these real quick. Okay, assuming you've paused the video and tried this, let's explore the answers. So remember, for the linear sequence, we have to find out what the common difference is. So you take the smaller one from the bigger one. So we can do 4 points, define the difference between them. So we can do 4.6, okay, minus 2. All right. We'll find out that these two become plus. So that will be 4.6 plus 2, which will be 6.6. Now, 6.6 is the common difference, but we have to think about what is really going on with the sequence. The sequence is increasing, so we are actually adding 6.6 every time. So negative 2 add 6.6 will give us 4.6. And then 4.6 add 6.6 will give us 11.2. 11.2 add 17.6 will give us the next number. Okay, remember what we learned about the geometric sequence. We'll say, well, what is the special number that we're using to multiply every time? How do we find it? We take the second term and we divide it by the first one. So we do 4.6 divided by negative 2. That will be negative 2.3. Now it means we are multiplying every time to get the next sequence by negative 2.3. So imagine that we have this first number. So if we were to do negative 2.3 times negative 2, you know that to double 2.3, we'll get 4.6. But we have two negatives multiplying each other. Okay, so negative, negative will be positive. That's why this is positive. Now, guess what the next one will be? It will be negative because we'll do 4.6 times negative 2.3 will give us negative. All right, so you can see our results. Okay, it's now time for you to pause the video and to practice what you've learned. Pause the video and answer questions 5 and 6 in 4 minutes. Assuming you've paused the video and you've answered the question, here are the answers. So here are the answers. For the first one, you were asked to find the outputs of these function machines. Okay, so we put negative 4.3 and then we add, subtract. So remember these two signs will become negative. Okay, so it's like saying negative 4.3 subtract 9.21. And then whatever you get, you multiply it by, of course, you will get a negative number. You multiply it by negative 5.6, and that will give you your number. Here, if you multiply this with that number, you would have a positive number. But now you have a positive number, these two signs will become negative. So if you have a positive number and then you subtract that, you'll get that number. Okay? And then here, these two signs will become positive. Okay, so you could use a calculator to do these calculations in one go. All right, but this is just to help you really understand what we have learned even without using a calculator. These two here will become positive. All right. So here you can do inverse operations to find the answer. So you take the output, you do 2,406 divided by 48.12, and then subtract, because remember these two signs are now positive. You're trying to find out what was put in by doing the inverse operation. Subtract 144.36. You're doing the inverse operation of adding. Here you will do 2,406, subtract that number, divide by that number to get that one. So you're doing the inverse operation. Inverse operation. Inverse operation. Okay? All right. Pause the video and answer questions 7, 8, and 9 in 6 minutes. Assuming you've paused the video and you've answered questions 7, 8, and 9 Here are the answers. So by now, you know how directed numbers work. So you know these two here will become negative. You know these will become positive. This will become negative, these two signs. And then the result is really a case of collecting like terms. Okay? You know that these two will become positive. These two will become negative. All right? Using your knowledge of what we've learned so far, these two signs will become negative. These two signs will become negative. These two signs will become positive. And then you collect like terms. Next, you're asked to find the next three terms in these linear sequences. How do we find the common difference? We're going to do that minus, so we're doing the common difference, the difference between them will be 1.76 minus 2.3. That gives us the special number. You can see that the sequence is increasing, so that special number is the number we're adding every time. Here, to find the common difference using your calculator, you would do minus 0.434, all right? You're trying to find the difference between them. Minus 0.37. My pen is moving. Okay, that's stable now. 0.37. These two will become positive. So that is that 0.434 add 0.37. So negative 0.434 add 0.37. That gives us the special number that we're working with. But notice that the sequence is decreasing. Okay? It's getting ever bigger negatives. So it means we are adding those negatives to this number every time, okay? Wherever, so we have these negative numbers, it means, adding a negative to a negative, you have bigger negatives, okay? All right. Here you're asked to find the next three terms in these geometric sequences. Do not forget, how do we find the common ratio? That's the name we'll call it. We do negative 7.2 for this one, divided by 2. Now, once we have that number, we know that is the number that we're having to multiply each of these terms by to get these. And that's the same we apply for these ones. All right, pause the video and answer questions 10, 11, and 12 in 5 minutes. All right, assuming you've paused the video and you've answered the questions, here are the answers. For question 10, you were asked to calculate the missing numbers to make the number sentence correct. Now, with these, you can do inverse operation. So you can do negative 4.2 times negative 4.2, all using your calculator. Once you get that result, you can divide this by that number. That gives you this. You can do the same here. Here, your result will be different. Remember, you can see it's not in bracket. So you can see why this will have to be positive, because here you'll have a negative number. So when you divide this negative number by that negative number, this will be positive. Here is the same thing. You can do inverse operation, but first you need to work this out. So these two will become negative. Pen is moving. Just a minute, sorry. Okay. So these two will become negative. So actually what you have is negative. Okay, that's another negative. These two will become positive. So that is 18 subtract 1.8. And then whatever you have, that result, you divide that by 0.18, and that will give you this result. Here, these two will become positive, and these two here will become negative. So again, you have 18 subtract 1.8, and whatever result you get, you're going to divide by 0.18. You would see that your result will be negative. Sorry, these two should be positive. Apologies. So these two negatives will be positive. And then when you finish, that will be plus. When you finish, you get that result. And then this one, you get that result. All right, for question 11, here you were asked, in this magic square, the numbers in any row, column, or diagonal add to the same number. So you simply ask to find a special way to create these numbers. So magic square, all the numbers in the row, column, and diagonal will add to be the same. So it's a very special exercise for you. Here, in the magic square, the product of each row, column, or diagonal are equal. So you simply work using inverse operations to get some of them and the others to get the result. I don't want this video to be too long, so I'm going to have to move on from that. Question 12, you were asked, create your own addition magic square using these numbers. Okay, and that's the result. And that brings us to the end of our lesson. So what we've learned so far is how to make effective use of your calculator to do directed number calculations, giving really careful attention to where you use brackets to make sure your order of operations are correct. And you extended your learning to include using directed numbers for linear sequences and for geometric sequences, even looking at challenging cases. Really well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself, and bye-bye.